4.1, analysis of functions, part 1. We're going to focus on increasing, decreasing, and concavity. And let me just do some grammar there. Okay, so we want to know when it's increasing, decreasing. We've already talked about this. Increasing means that the slope is positive. Decreasing means the slope is negative. So if I look at my function over here, I want to focus on the first derivative. What is the first derivative of this function? And we know it's 4x cubed minus 15x squared plus 18x. And we know that our slope will change from being positive negative or negative positive when the first derivative equals 0. So if I think about this in factored form, I can factor out an x, and I'm left with x times 4x squared minus 15x plus 18. And now I know that there will be a critical point That's when our first derivative equals 0. At x equals 0, we also happen to know, looking at this, if I put 0 in there, I get 0. So we know it's actually at that point. That's also a x-intercept. Let me make this bigger. All right. So if I look here, what I want to do is put a marker for 0. Let's say it's there. Then over in this area here, we want to know, is it positive or negative? If it's positive, hence the first derivative is greater than 0, then we know that our function is increasing. If it's less than 0, then we know then it's decreasing. So what I can do is I can look at my function over here, and if I pick a number like x equals -1, and I throw it in here, and now evaluate it. Let me just get rid of this so you can see it. Maybe I'll move it over a little bit. So I evaluate this function at x equals -1 because it's on the left of 0. And if I put it in there, put a -1 in here, and we know that's negative. And if I put a -1 in here, we got 4 plus 15 plus 18. So I know that's positive. I don't really care what the value is. I know it's positive. So I know that this whole side is negative. So I'm going to be able to say that the function is decreasing from -infinity, comma, 0, and we're going to use a bracket there. Okay. Now, if I look on this side, over here, I could pick a number greater than 0, such as x equals 1. And if I evaluate that, I get a positive times, if I put 1 in here, I get 4 minus 15 plus 18, which we know is going to be positive. So I know that on this side of 0, it is increasing. So we'll be able to say that the function is increasing from 0 to positive infinity. Okay, I can't use a closed bracket here because I don't know where positive infinity is. Right, so that's very easy to find out. Remember, this is when my, if I look at this, this was when my first derivative was negative or less than 0. And this was when my first derivative was greater than 0 or positive. Okay, I'm going to pause right there because you might want to then go try to find the increasing and decreasing intervals of a function and then come back and talk about concavity.